Hey Shubham. Okay, cool. So for folks who are in our uh, intro course, right? What one of the assignments that our advanced course students are currently working on is basically they're implementing a lot of different types of enemies with like different behaviors. So enemies start patrolling, and when they enter into a detection radius with a specific enemy, or the player enters into their detection radius, they start chasing that player. When they get close enough, they start shooting at that player. So that kind of a very simple use case for like how you implement a basic AI for enemies in the game, right? So that's the kind of example, and that's what we were just talking about. So that's what they are currently working on implementing. And with the power of sort of what we call state machines and MVC pattern, model view controller pattern, in the next sample, like we'll create a lot of different types of custom enemies with custom behaviors and custom things, and everything will just like once you have implemented the base logic with minor changes, you'll be able to create like 10 unique enemies with literally within a day, just because you've spent time building this base layer of a system which works as a core AI piece. Then you can add a custom AI piece for just a different kind of a patrolling behavior, just a different kind of a aggressive chasing behavior, and have kind of different mechanics for different players. So that's how these systems kind of build on top of each other. Cool. Any other questions, Setu? How's your progress going so far?
I work on the week two assignment right now, and I have solved those issues and completed it almost completed. I think it will be completed by today. Only the score update part is pending
Okay. So
on
you
the
have
UI.
the core MVC structure working, and now you're updating the score whenever you're shooting, right?
Yeah.
Got it. Were you able to understand all the interface stuff, especially how we use interfaces to make like collisions work, right? Like when you shoot from one tank, your bullet carries some information with it, and when it hits another tank, how does it detect that it needs to do a certain amount of damage to this other tank?
Yeah.
So that part was clear to you, right?
Yeah.
Okay, cool. Because that's one of the core pieces for pretty much all kind of uh, one entity communicating something to another entity without knowing about each other directly. So that piece of how to make things work in a scalable manner is super critical. Cool. Um, so have you guys started using? I don't think you have started using pull request or anything yet, right? Like, are you guys creating new branches? Others, Setu, Shivam, we discussed this in the last section, right? Like that, let's go ahead and create new branches for all the new features that you're going to add in. So that way we can um, do the code review process more easier and smoother. Not yet? Okay. Uh, for So literally just whatever you have so far, just push it out onto your master branches, and then start sort of merging, creating a feature branch for the current feature that you're working on, and then create a pull request for it. So I reviewed a couple of code bases yesterday or day before yesterday, um, and it becomes a challenge because then I don't know how much you've worked on in the last few days and what exactly you want me to review as well, right? So let's make sure that we're creating a new branch and pushing everything on the new branch. If anybody has any confusion about the pull request process, just let me know and I'll explain it again. All right, cool. We are missing a lot of people today. How's that? So give me 1 second. quick sort of overview of today's session a little bit as well. So um, I was actually sick for the last 3 4 days. Still pretty down with fever and whatnot. So invited guest lecturer from Siam. He's a graduate from Delhi College of Engineering or Delhi Technological University, and he's now just graduated this year, but he's been uh, training pretty seriously for like competitive uh, programming, and so he's super hardcore into data structures and algorithms. And he's been also, I don't know if most of you would have understood, like the coding blocks is a very famous sort of a training place where a lot of their focus is towards um, sort of weekend slash summer training for um, the whole sort of data structures and preparing students for campus placements, and specifically just focused around the data structures and algorithm parts. So he's super deep into that, and next next month in September he's actually flying off to Germany to join Google. So he'll be joining Google at the end of September, uh, as a software developer, and so he had the option of choosing between London and Germany, and he opted for Germany just because I guess he was getting a better team there or something. So he's been mentoring and training students at coding blocks as well, and he wasn't very excited about it because he was doing more of recorded video content, and for him he was more passionate about doing sort of live training sessions, what we basically do, right? So and we are also looking to kind of work with such sort of passionate people who are excited about the whole education space that we are in. So he wanted to join us in a part-time capacity, and so we are still in that discussion of figuring out how we can kind of expand on what we do to be even beyond just not just gaming, but beyond gaming as well, into other tech verticals as well. So this is kind of like a part of introductory session, and kind of even give you guys a little bit of overview and sort of an insight into the comparative programming side of things, because I'm sure a lot of the topics that we'll cover today, at least the third, fourth year students or people who have already graduated and recording it, like watching this recording later, would be able to relate to a lot of these topics. But here the focus is more towards how these topics are currently used, in the industry slash how companies, even top companies like Uber and whatnot, are using these for their interview process, right? So what kind of questions they ask when you apply for a regular software developer at, say, Google or Uber or Facebook or blah blah blah, right? um, for gaming, a lot of game companies won't go super deep into interview questions on data structures and algorithms, so it won't be very advanced level, but we will still cover at least the basics of all the core modules that pretty much get used, and a lot of these you'll start seeing use cases when we move on to working with um say the multiplayer pieces, right? So when you move on to building multiplayer games, uh, you'll start setting up a lot of data structures, um, which will help you kind of manage. So right now you're building a client for the game, right? That client knows about, predominantly in a multiplayer game, just knows about my player and all the players that you're playing with. So even if you think of PUBG, right, you have 100 players. So when you connect your device only has information about 100 players at max, at the start of the game, and when players die off, the number of players that you need to keep track of is still less than 100, right? But a game server, on the other hand, needs to manage your game and needs to manage every other game that's connected to that server, right? So if there are a million players in India playing PUBG right now, then that there are multiple servers, but assume if there is was one server, right? That one server is maintaining data for a million users, right? It has to process that data every frame the same way your Unity client processes things every frame. So the data structure part of it becomes very important. Making sure that you're using the right data structure, making sure you're using the right algorithms to process this data becomes very important, especially for those backend developers who focus on building servers only. Since our sort of focus is to make sure you guys are well rounded across the board. You have good understanding of how to build games in Unity, be it single player, be it multiplayer. Um, if you're doing multiplayer, you should have a decent understanding of how to build simple servers and get them set up. So a lot of the core sort of data structure pieces will start to come in when you start building like a basic server for a simple multiplayer game in say Node.js, and have to host it on something like Heroku or AWS or Google cloud services or anything. Anywhere we host it, the actual logic will write will have to have a lot of these classes, um, and like these model classes as part of MVC. The model part that we create, it's nothing but data class, right? So server is just think of a server out of the model view controller, and the services, it just doesn't have the view. Rest everything is the same, right? So if it's running your controller on the server for a tank, it has to do the same thing as what you're doing in the client. So server does a lot of duplicate work, but there are different ways how it does it, and it doesn't need to do everything. Just because it doesn't need to show a UI, the UI is obviously shown on the client. So those are the kind of things that kind of change up. But yeah, even for game developers, data structures and algorithms are super important. Um, Good companies will ask you questions around those. Most of them would ask you questions around basic data structure to understand that you understand these things, and especially if they see that you have used a data structure in a specific project that you have demoed on GitHub, right? Then they'll definitely ask you. So if you're using a dictionary, if you're using a linked list, if you're using a hash table, if you're using a stack or a queue, any of these data structures, right? This will become very important from like if you're saying that, hey, I've used these data structures and these are the projects that I've worked on, you should be comfortable answering questions on that. So that is definitely there. But again, the basic list of data structure, lists, arrays, stacks, queues, dictionaries, um, hash tables, these are usually the sort of, at least, yeah, these are probably the most common ones that we get asked in interviews. Shivam is asking, does Google have game developer jobs too? I don't think so. At least not in India. They might have dev jobs. Uh, so Google directly doesn't have dev jobs. So 2 years back, I was actually interviewing with uh, three years back actually. I was actually interviewing with this company, which is now under Google. I don't know if you've heard of it. It's called. It's an AI company in London. Um, Wait, what's their name? The company that built the AI for Dota 2, for AlphaGo. Does anybody remember? No, not OpenAI. OpenAI is Elon Musk's initiative. DeepMind, yeah. So DeepMind. So I was actually interviewing with DeepMind. So a lot of these AI companies are also now hiring game developers. The reason being, every every AI company needs software to train their AI, right? And what is this software? Game simulations. So the only difference is some might be using, say, Unity to build those game simulations. Other might be using uh, Cocos, or they might be using what OpenAI uses, like a Python-based framework for building some of these game simulations. So the idea is they're still hiring game developers because they need these simulations to keep running like literally a million times in every hour in order to train their AI. Uh, so it's a mix of game development and sort of software development, where you are, say, building a small game and then you're connecting it to an external server or a software where the actual AI is, right? So your data kind of goes from your game into this AI, and then it comes back as instructions, and then you use those instructions and run the next update for that particular game, and then the data goes back and comes back again, right? So that's how the AI kind of keeps training using these simulations. One of the examples is, one of my friend has a company in Delhi, and he's building software for companies that are actually using this self-driving cars. So a lot of companies that are working on different software pieces that go inside a self-driving car, right? Uh, they also use a lot of this Unity infrastructure to create simulations of a full city, uh, and actually have your car kind of drive around. So you'll have like AI behavior, like game AI behavior for like crowd, people walking around, crossing the street. Think of it like a simulation, kind of like a GTA, but much more realistic. Because the AI that's going inside it, you might set up like 5 cameras on top of the AI and take the feed from these cameras and put it into the actual AI software live when the simulation is running. So you have a Unity process running, you have a Unity EXE running, say, and then you have another software running that, and they're talking to each other through data, right? So a lot of like AI companies are hiring game developers as well, and obviously the more obvious ones are AR VR companies, ample shitload of them. So even like the my friend who's running this AI testing company for building simulations, he's working with Tata, uh, sorry, no, not Tata, Tech Mahindra. He's working with Tech Mahindra now, as one of their clients, and they are building some one of the pieces that goes into the, uh, I think, detecting about different road signs and whatnot. So he needs Unity folks to actually build simulations for like realistic looking cities and whatnot. So there's a lot more applications to uh, Unity being a very powerful sort of a tool. There are a lot more applications and generally generic use cases for games, much beyond just building games. So OpenAI, of course, is very popular. DeepMind is. I actually declined DeepMind after the first round of interviews. Didn't like what they were actually working on at that point, or at least the team that they were looking to hire for. So put that conversation on hold for a while, but never went back. so so yeah, DeepMind. I don't know if others are familiar with. Have you guys heard of this company called DeepMind? Known about it, what they do, what they don't, etc. Anyone? Okay, doesn't look like, no. Okay, so definitely check out DeepMind. They are they're definitely sort of more of a generic thing. So if anybody's using Android 9.0 on their phones, then it has this adaptive battery thing, which basically runs a simple AI which checks for what time of the day is your battery usage high, what kind of apps are currently high using high battery, and it kind of predicts what your battery usage will be throughout the day, so it can let you know before and kind of optimize battery usage, right? So that was the first mobile application of an AI that came out of DeepMind, and directly used by Google. So Google bought them a couple of years back. Um, so so that was one application, and now it has rolled out. The actual use case has rolled out in Android 9.0. uh, the other one is basically Google has these huge cloud centers, right? Data centers where all the servers are running. So when we build an application, or when any company builds an application on Amazon or Google Cloud or anything, right? They have these huge data centers. The problem with this is you have like 150 servers in one huge room, each running at 100% capacity, they generate a lot of heat. So a lot of work and research has gone into how to cool these systems, and cooling is actually one of the biggest cost for any data structure. It sounds surprising that, hey, put a AC, like a room, you have an AC in every room, just put that, right? But that doesn't work. The temperature needs to be very finitely controlled in order to drive the best performance out of it, etc., etc. So like the, these systems generate a lot of power and a lot of heat, and because of which they need to be effectively cooled. So the first application out immediately after buying DeepMind, what Google did was they got a collaborative project going, and they got uh, uh, DeepMind to figure out how they can use this adaptive AI to circulate their cooling systems, right? When should it cool and how much should it cool in order to keep it effective? And they reduce their bill by 30%. Um, and 30% literally means, millions and millions of dollars every month, if not every year. Um, so that's a huge saving for any company that's in the cloud space. They want to use anything about AI, anything. If they have a cloud system or a cloud server running, then they have some physical data center somewhere where these servers are running. Um, Cooling is a big part for them. So that was one very big sort of work that came out of DeepMind. And of course, DeepMind, the more obvious ones are they recently built a Dota 2 clone, um, a Dota 2 AI that actually beat 5v5 Dota 2 World Championship team. 2 years, 1.5 year back, they beat a one-on-one player, and people are predicting that 5v5, an AI would be able to beat a 5v5 player team in like 10 years from now. But that happened this year or last year, I forgot. This year, I think. Yeah, this year, 2019. So it's a huge sort of leap forward on how they're doing things. So AI is also a very exciting space. And when you talk about AI, people think, oh, we don't need anything to do with game development or anything like that. But actually, that's very ignorant, because fucking AI in the world more or less uses some sort of a game to actually train. So when the people say that, hey, we don't need AI, yeah, we don't need gaming, that's very amateur to say that. Shivam is asking, is AR VR development good to get into? So AR VR definitely is something that's catching a trend. It's not mainstream yet. Depending on in which part of the world you look, it's a lot more. The adoption is a lot more for AR and VR in general, specifically VR, um, in US and in Europe, just because people have higher spending capacity, and especially for VR, the devices are much more expensive, and you need dedicated devices, right? So in India is still a big question mark yet. Um, we are definitely some time away. I don't think anytime within the next 5 to 10 years that VR is going to become mainstream. It will definitely not become mainstream as a media or an entertainment source, but it will become mainstream as a uh, in certain other industries. So, to give you a couple of examples, so medical space um, is one which is heavily investing into VR, where you have uh, uh, there is a shortage of really good uh, doctors, right? So if you have a very trained neurosurgeon sitting in some part of Europe and he wants to conduct a surgery in a small town in somewhere in Africa or India or wherever, right, where there isn't the talent isn't available immediately, then you can use a lot of these uh, as kind of virtual collaboration environments where people are there physically and observing things, looking at their perspective and guiding the whole process, right? So things like that can be really sort of helpful, but in specific context. So Indian Army is investing into VR systems now. I know a couple of companies of my friends who are building tools for the army, for training new recruits using VR. Because if you imagine, right, like uh, army, firefighting, uh, how to fight when uh, the what are these sort of emergency response teams, right? The teams that respond when there is an earthquake, when there is a natural fire, uh, things like that, right? These are scenarios that are very hard to replicate. How do you train a medical professional to go inside, to go into a war zone and actually treat patients without really simulating a full freaking war, right? That's just not possible, right? So there are these kind of simulations where the real world thing is so damn expensive that VR becomes a very convenient way for people to train. And One of my professors from Carnegie Mellon has a company doing just that in US, and they've been in operation for 10 plus years now. So like there are companies that are purely focusing on this segment of industrial training, right? Like when you're dealing with, say, radioactive chemicals, how do you train somebody when there is a spillage in a nuclear plant, right? So things that are very hard to reproduce in a real world in a cost effective manner, VR comes in as a training equivalent of that kind of a thing. And the same thing is actually visible in your self-driving cars, right? It's not easy for Google to throw out a self-driving car and just let it train while it keeps hitting people and bumping into things on the way so they can improve their AI, right? No, they use this. They don't use VR because they're not training a person, but they use this virtual environment as a simulation to train this, right? So if you're training a person, you put them through a VR headset so they can use that same lens. So a lot of companies are now doing this VR training as a module as well. So AR VR is good to get into, but as a industry, there is time before it kind of sees adoption. Cool. Energy is saved. It's daily lives. So for VR, need the headset 65K plus GPU at least. Yeah. Um, so definitely VR is definitely not something that's going to hit mainstream anytime soon. You might see VR based theaters where PVR is investing in like a VR headset based experience, and you go in, sit on the seat, you buy a ticket, you put on the headset. In $300, you can watch a VR movie, right? So you'll see things like that kind of coming up within the next 5 years, but I would not bank on saying that VR is going to become the mainstream thing anytime soon. So I think Sam is there. Just give me one sec. Uh, okay. Whoops. Okay. So we have Sam here. Hey Sam.
Hey, hi. Uh, I don't think the webcam is opened up yet, right? I'll start the video.
Okay, just try. I gave you host access, so you should be able to pretty much control everything. Uh, Go ahead and share your video if you can.
Yeah, I can share the video. Can you see me?
1 second. Yeah, I can see you.
Yeah, so just a second.
How do I get? All right, so I'm gonna try and put you up. Cool.
Yeah,
So, 1 sec. How do I change the speaker view on this to be just you, so that people can focus on you and not me? Uh, can you go full screen from your side?
full screen as in? Yeah, this full screen.
1 sec, 1 sec. Yeah, I think I. Yeah, I guess you guys are seeing my photo as a full screen thing, right? Everyone else, I'm guessing. Yeah. Okay. Cool. 1 second. All right. Let me just stop my video. Maybe that helps. All right. Cool. So, do you want to just quickly start with your sort of introduction? I gave a brief intro to everybody, so they know a little bit about you. But if you just want to take it, go for it.
Just a second. I'm just seeing how I'll screencast because I need it. few times in between, so I'm just checking.
Cool. All right. So you're
Help
super
me out, there's this screencast thing. I'm not able to find it. I've not used Zoom before.
So you just want to share your screen, right?
Yeah.
Yeah. So there should be a share button at the bottom panel. Um,
Okay. Yeah, it's there. Okay. So, like, can I have the video and the screen simultaneously? Like the share and the video, like wherein I'm explaining things.
yeah. So you're good with that. I think everybody can see your small video in the corner and they can see your entire screen. If anybody doesn't see that, just please let me know. But I think everybody should be able to see Siam as well as his screen.
Yeah. So basically, the first of all, the screen is important. It contains the topic.
All right, cool. Yeah, all right. I think everybody should be able to see. Yep, cool. Go ahead.
Yeah. Just a second.
So if you have a presentation, you can directly try and present from there itself, so that people can see you as well.
Yeah, I'm just presenting.
Yep, cool.
Is it like, are you able to see
Yep,
the value programming thing? Yeah.
yep.
So, so first of all, I'll introduce myself. My name is Sayyid Gar, and I have been quite enthusiastic about competitive programming. Like, am I audible to all of you? Like, you can just send in a yes. I can see it.
Yep, I'm good. I
Yeah.
can hear you clear.
Okay. So my name is Sayyid Garg, and I am quite enthusiastic for competitive programming, and I have been quite enthusiastic for competitive programming for the past 4 years of my college life. My college life has ended now, so I am a graduate now. So the point is that I'll be teaching dynamic programming today. That's the whole motive, and I like teaching a lot, so that's why I want to do these live classes thing. So that's the entire thing from my side. No further introduction is required, right? That's enough, right?
Yep, they know more than that. All right, cool. Take it away.
Yeah, just a second. I'm fixing the marker. Yeah, it's done. So let's start with dynamic programming for today. So I'll make the view more clear to you. So first of all, let's see what's dynamic programming all about. I'll write the topic. It's basically known as DP. I'll not share. So, like, can you guys zoom the screen and like zoom this first of all so that you can see it more clearly? I don't need the screen share right now. I don't need the because I need a bit of explanation before that.
Yep, done, done.
Yeah. So whenever I'm explaining on the board, then you guys can zoom this one, and whenever I use the screen share, then you can zoom that particular one, right? Is it cool with everyone?
Cool. I'll control that. Not an issue.
Yeah. So let's start with DP for today. So what's dynamic programming all about? Dynamic programming is a widely asked topic. So basically, it's like for interviews, it's meant to be for interviews. Like the interviewer can get a very good grasp of your entire knowledge by just having a question on dynamic programming and making you try to solve it. So that's the entire thing. So you should not prepare it from the perspective of interviews. I never prepared it from the perspective of interviews because these things come and go. But yeah, for the learning part, dynamic programming is really a good thing because it helps you. Like if you are a mathematical person, if you like maths, then obviously you will fall in love with dynamic programming. So that's the entire philosophical thing regarding dynamic programming. Now I'll jump on to more technical details. So yeah, can you open this link? Like I don't think that you can open this link. I'll open the link so that you're able to see it. So this is a very simple question. What is dynamic programming? So I'm considering that your knowledge regarding dynamic programming is nil at present. So I'll be starting it all from scratch. So the point is that we should see the definition that comes from Quora, and how should I explain dynamic programming to a 4-year-old. So let's see this. You can give it a read, but it's very simple. Actually, if I have 1 plus 1 plus 1, many ones written over here, just like this. So let's assume these are the 4 ones. So my sum is actually 4 over here, right? Now, what happens if I add a 1 just before it, right? So if I add one more 1 over here, then it becomes 5. If I add one more 1 over here, then it becomes 6. So are you able to imagine that why you are able to calculate it so quickly, like with such an ease that, okay, so if I add one more 1 over here, then it becomes 5. This is just because you have already pre-computed, or you already have that preconceived notion that this entire thing is 4. So if I add anything before it plus 1, so it obviously has to become 5, right? So this is the entire thing that's being explained over here. So even a 4-year-old can get it very easily. So the point is that this is how things progress in DP. So basically, DP is just memoization. Memoization is quite a big term that's being used, but it's basically saving what we know in the memory, just as simple as that. Saving what we know in memory, right? So you need not go into the depth of what's memoization. It's simply a term used for saving things in memory so that I can use them later. So that's just the thing about dynamic programming. So it's a very basic idea of how dynamic programming is and how it progresses. So I'll get on to further details of it as we go on further. So let's jump on to the next thing. It's overlapping subproblems and optimal substructure, right? So this is a link. I'll open up the link for you. So you guys can give the link a read as well. I just wanted to know that was the basic intro part of dynamic programming clear, like the 1 plus 1 plus 1 thing, right? That's quite an easy part, right? You can just reply with thumbs up, yes, or anything like that. Okay, let me see. Yeah, so let's start with this optimal substructure thing. Yeah, so now, what is an optimal substructure and what are overlapping subproblems? That's the thing we are going to discuss today. So starting with optimal substructure. This also may sound a little weird, but the meaning here is very, very simple. Let's assume that you are standing on a city, or you are present in a city A, and you need to go to a city B, right? And let's assume that the shortest path to go from city A to city D passes through city B. So now the thing is that I'll write it out that the shortest path from A to D passes through B. Right? So basically, I'll be using B as the intermediary city for going from A to D. Right? So one question that I have for you guys is that now I'll reach B from A. Then what after B? Do I need to take a shorter path from B to D, or I can even take a longer path? I need to go through the shortest path, right? So the point is that if I need to go from A to D, then if I'm going from B, then I need to also take the shortest path from B to D. I cannot take a longer path from B to D because that would not make sense, because the point of shortest path would not be like it would not be clear then, because this is the optimal substructure thing actually. The B to D is a substructure. So that substructure or the subpath should also have a minimalistic distance, right? If I want to optimize the distance from A to D, I also need to optimize the distance from B to D. That's the thing for optimal substructure, right? So like B to D here is the common part, like it is the part that has, which is a substructure. So we need to optimize this as well. So that's the entire thing. The distance from B to D should also be minimum for the distance from A to D to B to D, right? So that's the example that you can find out, which is mentioned in this link. Um, so it's this simple. The point is that whenever you have optimal substructure, you can actually use both greedy and DP things. But whenever you have overlapping subproblems as well, then that is the case when DP actually comes into picture. So I'll start with overlapping subproblems now. Are you guys aware of Fibonacci numbers? Like, Mayank sir, can you tell me by seeing the replies, like if every one of them is aware of Fibonacci numbers?
Sure. Okay, cool. So far we have all yeses.
Okay, so the point is that if you are aware of what Fibonacci number is, I'll just give you a brief of it. F of I, basically the ith Fibonacci number is equal to f of I minus 1 plus f of I minus 2, right? So basically, if my first two Fibonacci numbers are 0 and 1, then I can get the entire range of infinite Fibonacci numbers. Like this, the second Fibonacci number would be 1 plus 0, which is 1. The third Fibonacci number would be 1 plus 1, which is 2. And similarly, the third Fibonacci number would be, sorry, the fourth Fibonacci number would be 2 plus 1, which is 3. So it's as simple as that. But now let's visualize the Fibonacci numbers using a tree. Okay. So I'll be using a tree over here. This is f of 3, right? Now f of 3 basically is a summation of f of 2 plus f of 1, right? And f of 2 is basically a summation of f of 1 plus f of 0. F1 and F0 are basically known initially. So to calculate f of 3, I need to calculate these both and later on these both, right? So DP is basically memoization with recursion. So basically we'll be using recursion part because of the overlapping subproblems, and then we will be memoizing it so that our retrieval is faster. We'll see why we'll be memoizing it. So f of 1 is just present over here. Right. So now you can very easily see that this f of 1 basically is present at both of the places, right? So basically reaching the same person two times over. Now let's go beyond this. Let's say we have to compute f of 4, right? So f of 4 is basically f of 3 plus f of 2. Now for f of 2 part, I need to make the entire tree again, f1, f0. Yeah. So now the point is that you need to see that these two things, these two trees are actually the same and are being computed again and again. So let's assume I'm writing a small function over here. So if my function is f of n, then or instead I'll write it on some online platform so that you can see it here only. So are you able to see the coding screen right now? I've opened Sublime.
Yep.
Okay. So yeah. Now the point is that let's write a function that calculates Fibonacci numbers. It won't take more than a minute. So I'll write it as int f, and in then you do not need to care about what's written above. That's just a template that's being used when you write bigger codes. For the simple code, it's not required. So if n is less than equal to 1, then I simply return n. This is basically the 0 for the 0 and the 1th Fibonacci number. And going beyond that, I return f of n minus 1 plus f of n minus 2. So this is basically the recursion tree of what I just explained, of the code written over here. This is just the recursion tree of it. So now, if I want to calculate 4, so I'll be printing cout f4. So the fourth Fibonacci number is actually 3, right? So my answer on the output should come out to be 3. And yeah. So you can see that the output has come out to be 3, right? So if I go beyond this, I want to calculate the fifth Fibonacci number. The answer would be 5, right? So hopefully this idea is clear. But if I want to write something like find out this 10 to power 5th Fibonacci number, then this would not actually execute even. Maybe this is because there are many subtrees that are being calculated over and over and over again. So see, the program has stopped, and actually it will lead to a stack overflow, and my RAM would be consumed. So I'm stopping this file because then it will consume all my RAM, and I'm not able to even talk to you on a video call. So yeah, so that's the entire thing. We weren't able to compute the 10 to power 5th of Fibonacci number by using this entire tree. This is because you need to realize that we are computing things again and again. Like F2 was computed once, but here F2 is being computed again. Like they are being computed, and so if I am going to the 10 to power 5th Fibonacci number, F2 is being computed, I don't know, 10 to power 5 times. F1 is being computed more than that. So that's the basic issue that we have reached over here. So that's why we are not able to print it. So is there a solution by which we can print it? So first of all, let's get back to overlapping subproblems. So the point is that for F3, I was needing this entire tree of F2. And for F4 also, I'm requiring this entire tree of F2 once again. So basically, F4 and F3 have these things in common. So that's the thing, overlapping subproblems. So F4 and F3, both of them have a problem of F of 2 that is an overlapping subproblem for both of them. Like both of them need to solve F of 2 problem. So if these can be regarded as problems, then F4 and F3 have a common problem that they need to solve, that is find F2. So that's the thing. And that's why the name comes overlapping subproblems. But the point is that how can we compute the 10 to the power 5th Fibonacci number, right? So actually 10 to the power 5th Fibonacci number would be exponentially large. So it is the case that we cannot even store it in a very big number. Like we cannot store it in long int even. So in that case, I'll be printing the modulo of that number 100, right? But still, since it will lead to a stack overflow, my function would be called again and again and again. Therefore, I'll not be able to get to the answer. So how can we do it? So here is where DP comes into the picture. If I have computed F2 once, then I would never compute F2 again. So I'll store the value of F2 and I'll use it for later purposes. So let's assume that if I make an array, now you need to see the screen now. So if I make an array of size 2 into 10 to the power 5 and I name it DP, then this is actually dp of n is equal to fn minus 1 plus fn minus 2 modulo 100, right? So basically, we are preventing this calculation over and over again by just storing it once in the DP array. So now, if I try running, I'm printing the value, so it will get printed very easily. Okay, so let's wait to get the solution. Yeah, I've written the things correctly. Just checking it. Okay, so basically I have written the entire thing correctly, but there's still an issue. It's computing this thing and over again, right? Still it's computing. I'm saving it, but I'm not using the save thing again, right? So that's why I initially set each one of them to -1. Yeah, and basically if my DP at that position is not equal to -1, right? If at a particular position the value is not equal to -1, basically this means that it has been computed, right? So I simply return DP. Else, if that value has not been known yet, then I compute it. So now it would actually give me the answer. So this is the entire thing for memoization. You need to memorize it, but you also need to use it. So we are getting 75 just to verify f of 5, because f of 5 should be 5 because modulo 500 doesn't matter over there, right? Yeah, so I'm getting 5. So basically that's the correct code for writing Fibonacci numbers. So I just told you how we can use DP on Fibonacci numbers so that its calculation becomes easier, and like we can calculate for very big Fibonacci numbers, right? So which we weren't able to compute just by writing a normal recursive function, right? So is it clear to everyone? So that if it's not clear, I can again explain the code to you.
Quick question. So why did we do memstat specifically -1? And can you just one line cover what memstat exactly is as well? So just so that everybody's on the same page.
Yeah, so basically we memset dp to -1. So basically I am memsetting dp to -1. This means this is just I need to memset dp. Memset basically means to fill the dp value, dp array with some values. Okay, so I can fill it with -1, I can fill it with 100, I can fill it with any value. But the point is that I need to fill it with some value which actually does not occur as an answer, right? So -1 can never be a modulo 100, right? Considering positive numbers only, then they cannot have a modulo 100 to be negative, right? So that is why it is safe to use a -1 memoization over here, so that I know whether that number has been computed or not. So if it has been computed, then its value is for sure not equal to -1, right? And if it has been computed, like there are two cases, right? So if the dp at n is calculated, then it will surely have a value not equal to -1. And if the value is not calculated, then it will have a -1 for sure. But yeah, -1 would be replaced later on with some value modulo 100, which obviously would not be equal to -1. So each time I visit a particular position, I know whether it has been computed or not by just checking this simple thing, which is being mentioned in the line 86, right? So any doubts?
Looks good. Right. Any other questions? Okay, so Shubham has a question. We need to adjust the modulo as per our input numbers. So I guess the question is like we did a modulo 100, but why 100? Why couldn't it be 1000? Why couldn't it be 5? Or why couldn't it be some other arbitrary number?
Very easy question. Like it's a good question to be asked, but not a good question when you know Fibonacci numbers. The point is that the range of any integer goes up till 2 to the power 31 minus 1, right? in the positive numbers. So you can have any number which is less than equal to this as the modulo, but it should be greater than 1 as well, greater than equal to 1, because modulo 0 doesn't make sense, right? So you can have any number from 0 to this number in the range, but the point is that if I see the growth of Fibonacci numbers, then it's exponential. Basically, it rises in the powers of 2. Let's see 0, 1, 1, 2, 3, 5, 8. Now the next Fibonacci number would be sorry, 13, and so on. So basically, the growth here is exponential. That's the issue. 13, 8, 21. So every time the number is getting almost doubled. So that's the issue. So once you reach 60th, 70th Fibonacci number, then actually it would have exceeded the int value. So that's the issue. That's why we have to have some modulo for here, a modulo over here. And so modulo 100 or modulo 1000, any modulo up till 2 to the power 31. So even if you want to increase this range, you can make it long int, and you can go up till 2 to the power 60. So, but you cannot go beyond that. So even long int wouldn't be able to procure more than 70, 80 numbers. I'm not pretty sure of the entire exact number. That would be the end part, but that is the entire thing. So you can have any modulo. It should be non-zero, and yeah, that's the entire thing, and it should fit within the range of the integer or long. So is it clear?
Cool. I think it should be. Yeah. All right. Cool. Yeah. Looks good. So modulo. I had a random question. So modulo is just letting us know that this is modulo 100, right?
Yeah.
That 10 to the power 6 or 5, whatever a number that we picked, the Fibonacci of that is 100x
Plus
plus
7.
75,
Yeah.
right?
Yeah.
But if the question is that I want to know the exact number, actually, here we were saying that we're going to calculate Fibonacci number of something, but we didn't really calculate the Fibonacci number of something. We just gave you an actual thing that tells you that, hey, we were able to calculate it.
Yeah.
So why the difference?
There's you can even calculate that. There's a library in C++ which is named as Begin. Okay, so if you make this array as Begin array, then you can calculate any Fibonacci number that you wish. Okay, so there's no restriction, but the only point is that in competitive programming or in any other programming, you'll not be you'll not be basically asked. They just make sure that you know how to calculate things, but you do not know the exact number, right? So if you want to test someone, that's the way, right? We ask the person a question, and if he's able to get some sort of question to be correct, then it's done. So the modulo is so unique thing that if I have some prime number, very large prime number over here, then it's very rare that a person with a long code can get a correct answer, right? So basically, this is just for competitive programming that we use some modulos thing. They generally use modulo of 10 to the power 9 plus 7. But if you have a big int library, you can very easily use it. In Java, you can use a big integer and you'll surely get the number, whatever Fibonacci number you are trying to search for. So that's the thing. But yeah, in general, obviously, we do not find any much use of such big numbers, because these numbers actually exceed crores like very easily. So our normal human brain doesn't go beyond billions or trillions. Like, we do not find sense beyond that. So that's why it's not that practical. But yeah, if you want to compute it, you can use big int library or any other library which computes big integers. In Python, even if I write the code, then you'll get it normally, because Python has no such restrictions.
Cool, makes sense.
So is it clear?
Yep. Any guys, any questions so far? Please put them in chat or just unmute yourself.
Yeah, unmuting would be a better option, because
Yeah, usually, yeah, but in case somebody doesn't have a mic or something, just put them in chat. So far looks like we have no questions, so I think we can move forward.
okay. So I'll go back to the screen. Yeah, so we are done with the overlapping subproblems and optimal substructure thing. Now I'll jump on to top-down versus bottom-up. Right? So there are two ways of computing DP. One is top-down, and the other one is bottom-up as written. But let's start with bottom-up first of all. So, like as you can read on the screen, this is a very good example. So, I like when I started competitive, I didn't see this example. I thought that okay, this I saw two people score. One person had written bottom up and the other person had written top down, so I got it. But I wish I would have known that such thing exists. So let's start. Like if you want to become an amazing programmer, so these are two steps of becoming an amazing programmer or analyzing how you become an amazing programmer. So bottom up step would be that I'm going to learn programming, then I'll start practicing further, then I'll start taking part in contests, then I'll practice even more, and after that I'll become an amazing coder, right? So this is basically going from nothing to becoming an amazing coder, right? So bottom up is basically starting from nothing and going on to everything, you can say, right? Means you started from a noob and you became an amazing coder, right? So that's basically bottom up for you. Now top down. So a person who's a protectionist, he would think in this manner, like he would think of in a top-down manner, he would not think of in a bottom-up manner. So that person would say, okay, I want to be an amazing coder. But how? Then I'll work hard like crazy. Okay, then how? I'll practice more and more. That would become how. So basically in your imagination, top-down is basically about imagination, how our imagination goes. So we think that we'll be becoming a good coder, but then our brain asks us the question, how will you become a great coder? You don't know shit. So then you'll ask yourself that, okay, I'll work hard, but in what field will you work hard? Okay, so I'll be working hard in competitive programming, or basically I'll be taking part in contests. So, but how will you be able to take part in contests? Because I learn programming, I learn some language, and then I practice it. So basically, top down basically thinks that okay, I have computed everything. Like I'll manage somehow how the further details would go, but I'll first think of the biggest situation. So I'll go from everything and try to figure out how to reach there from nothing. Okay, so that's the basic detail for top down and bottom up. So is there any issue with it? Like the DP which we wrote right now, the code which we wrote for Fibonacci numbers, can you guys tell me that was it top down or was it bottom? I want to know your answers. You can write it on the chat. Was it top down or was it bottom up? I'll share that screen with you again. So I really want to know your answers so that I can get a good grip of whether you're getting or whether you're understanding things or not. So just a second, I'll be sharing it with you once again. Yeah, so this is the code, and now you need to tell me just a simple question whether it is top down or bottom up. So, sir, can you tell me where I can access the chat? Yes.
Yeah, you should have access to the
Okay, so one person has written top down. Okay, two have written top down, one has written bottom up. Okay, Vijit has written bottom up. I'd like to know from this person that why bottom up? Like, what's the explanation? Or is it just a random guess? Can you unmute your audio?
I think Vijit might not have a mic, so
Yeah,
but I mean we can probably Adarsh or Setu, one of you can explain why do you think it's top down? Okay, Setu, go.
Yeah, actually, first we tries to check if the highest value, the value for the highest number is already calculated. If it's not there, then we will go down to the next low value, and so on. So I feel like it's
that's the
top.
correct explanation. So that's the entire thing. So basically, we were trying to find out the fifth Fibonacci number. We simply jumped on to finding out the fifth Fibonacci number even before knowing that what the other Fibonacci numbers were. So that's the thing. So that's why it is top down and not bottom up. So I'll now jump on to quickly writing the code for bottom up Fibonacci numbers. It is very simple. So this was the code for top down. I'll switch the window and I'll write the code for bottom up as well. I'll name it as bottom up. Yeah. So now bottom up doesn't require any function sort of thing. You can have a function, but yeah, it isn't required much. So bottom up would actually put on some values. F0 is equal to 0 and dp0 is equal to 0 and dp1 is equal to 1. Now I'll be jumping from I is equal to 1 to I is less than equal to, sorry, I is equal to 2 to I is less than equal to 10 to power 5, I plus plus. And dp of I is basically equal to dp of I minus 1 plus dp of I minus 2, right? And if I want it to be modulo 100, then I'll do it like this, and I'll be printing dp of 10 to power 5, right? So it should, we know that the correct answer is 75. So let's see whether we are able to reach that answer or not. Yeah, so we have got a 75, we have got 75 as our answer. So the point is that this is a simple code for bottom up. So basically, as we saw from this example, that how we are becoming an amazing coder, we are just learning the things one by one. So basically, to calculate the 100 Fibonacci number, if I want it, then I'll go from F0 till F1 and so on up till F100. This is how bottom-up progresses. However, top-down would actually be going in the reverse order. It would be calculating f of 100 and using f of 99 and f of 98 and so on. Right? So basically, they both have their trees, but actually the tree is more evident in top-down. In bottom-up, you see things calculating like this only as normal iterations in an array. So yeah, you're not able to see a tree in bottom-up. But yeah, bottom is also a tree. Basically, it's just memorized, right? So that's the thing for coding dynamic programming. Any doubts?
Anyone?
I'll be seeing the chat if someone has written any doubt. I don't think anyone has written.
No, so far no questions in chat. Cool, guys. If you are following, just let us know in chat. Any questions so far? Okay. All right, cool. Looks like no questions.
Yeah, I'll get back to the next slide then.
Okay, one question. So Adarsh is asking which one is a better approach?
Just a second. Which is a better approach? Okay. Yeah, so that's a good question. That's seriously a good question to ask at this point. Which is a better approach? So bottom up is always optimized. Can you guys think why bottom up is more optimized in comparison to top up? Because the point is that we are going into simple iterations. We don't need function pointers. We are not storing things on stack and then going again in the stack, like the function calls. They are not being stored. So it prevents many of the jumping in the pointers and stuff like that. So bottom up always has an optimized code in terms of time and in terms of ease of code. Okay. The code for bottom up will be quite easy, but yeah, top down is the way I prefer always. Why? Because it's less optimized, but the good thing over here is that even though it's less optimized, Yeah. So the good thing over here is that even though it's less optimized, it's easy to think. Like we don't need to care that our code looks good or not. It should work, right? At the end of the day, every one of us thinks that it should work and we should be able to visualize it, right? So easy to visualize. That's the thing over here. The code you're able to think of things easily, like right? Because in the Fibonacci also, if you know that f of n is equal to f of n minus 1 plus f of n minus 2, then you send it simply to the recursive function and you get your answer. But here you need to actually, so basically top down is easy to visualize in your mind, right? So you give the task of visualizing to your mind, and the code is obviously normal. But yeah, bottom up code would look easier because it's normal iterations, and this is basically recursive functions. So that's the basic difference between them. That it consists of recursive function calls, and this is consists of iterations. So yeah, obviously if someone has written a good iterative code that consists of 4 loops, obviously you'll find it easy to read that code. But yeah, this code would be easy to visualize, and in some cases, this code even would be easy to see for a person who's visualizing the or who is seeing your code for the first time. Because if someone has knowledge of DP, then yeah, top-down code is also simpler. But yeah, bottom-up is more optimized technique. Like if you write the same code, then maybe it runs in 1 second if you write it bottom up, but it may take up to 2 seconds for top down. But yeah, that completely depends on how you write the code. But yeah, obviously, bottom up code is more optimized. That's the thing. In a recursion, always top down. I'm reading the question. Is recursion always top down? Yeah. So basically, recursion means top down only, right? I could have also written a code which is something like this, right? I'll get back to the screen so that you are able to see things. You can see the screen that I'm sharing. So dp of I, I'll see whether I'm sharing the screen or not. Just a second. Cool. So basically, I could have written this function again. This one. Just a second. Yeah. So basically, this is a good mix of writing the code as top down and bottom up as well altogether, right? But the point is that recursion. So basically, it's not necessary that the question which you have asked is that if I've got the question correctly, is recursion always top down? So basically, here I have made it bottom up, right? So the point is that recursion top down obviously makes more sense, right? So basically, if you are trying to solve a particular problem, let's say we have some problem x in our hand, and it can be decomposed into two further problems. Let's say x minus 1 and x minus 2, right? So we can consider that x. I have some problem x that I need to go to the school, right? So f of x minus 1 would be that I need to pack my bag, and second would be that I need to put my lunch in it. So basically, I need to solve these two problems first to get the answer to this problem. Right? So this is basically how recursion would look like, right? And the top down obviously means that we have to calculate the answer. We are not knowing it, right? So it has to be recursion anyhow. It cannot be iteration because I don't know how much I have to iterate, right? So that's why the point is that for top down you need recursion because you don't know how many iterations you have to perform. If you know how many iterations to perform, then you'll go bottom up, right? That's the case. And is there some kind of middle out approach too? Yeah. So I coded the middle out approach for you, like which used bottom up and top down as well, but it's useless. You should just go one way and not take both of them. So I coded both the ways for you. So, but it's bullshit. Don't ever code like this. Yeah. So any other doubts?
So why not use the middle out? You said you don't ever code like this, but why?
It doesn't make sense, right? Because if you are trying to code this, like this code, I could have made this code simpler anyhow. Like I could remove these 3 lines, or I could remove this entire function. Right? There are 2 ways to make this code simpler. So why to make life tougher for you? So it's not a good coding practice. Obviously, in any code, like it's not necessarily that we need to do it in competitive programming only. The code should always be smaller. Like every company, every production code, everything is preferred to be small and precise, and like we should get to know what things are happening, right? So it's never preferable to write big codes for which can be cut down to shorter codes, right? So that's the entire thing. I'm not recommending it. You can use it, but it's not recommended. That's the entire thing.
Okay. No, mainly like, so one thing is that, okay, it probably doesn't make sense in this scenario,
Yeah.
but does it not make sense any time to use a hybrid approach?
No.
Um, or only is it because of this scenario specifically that we're talking about? It's not recommended, and maybe in other subset of scenarios it is recommended. So just a broader question at large, right?
Yeah. So it's very simple. Like DP is all about finding an answer for a particular state at which you are, right? So I want to calculate the answer at this state, right? I can go bottom up, top down, it doesn't matter, right? This is a particular state. I need to reach a particular smaller state maybe to calculate the answer for it, right? So this may be the flow for top down. But the point is that if you are calculating this state, you just need to use one way, right? And the code remains same for everyone. That's the thing. The point is that if you are trying to calculate a particular state in DP, then the code for every state is the same, right? Because that's what DP is all about. DP is basically a function, like it's a recursion, right? Recursion means I'm running the same function again and again on other numbers. Now this thing comes from overlapping subproblems part, right? Like each one of them is trying to solve a subproblem or optimal substructure. Yeah. So basically, I was trying to reach to D from A. I wanted to go through a smaller path. So the same condition is from B to D as well, right? So even the smaller states have the same conditions on them. So I'll be actually running the same code on them again and again. So either I use it in an iteration or do it in a recursive function. Why I require both of them, right? Means it doesn't make sense to have a middle out, like a middle approach. There's another question is that well, tabulation is approach in which uh, tabulation is approach in which method, top down or bottom up? Like, can you are you having Anantam? Are you having the mic with you? Like, can you tell me your question more because I'm not getting the tabulation. Can you please unmute yourself and tell me? No, you aren't having the mic. So, what's tabulation? Like, it may be a term, but I'm not knowing it. I'm not that good with terms, but yeah, we should be good with concepts, right? What is tabulation? Can you please let me know?
Yeah, Anantam, just kind of try and explain what you mean slightly in more details, and we'll come back to this question once you have. So I think we can move forward,
Okay.
but once Anantam has kind of laid down some more details around it, we'll jump back to it.
So let me go beyond this. It is a concept in dynamic programming. Okay. Tabulation is approach. Okay, just a second. I'll Google it. Uh, tabulation in DP.
Yeah, geeks for geeks to the rescue.
Though I never would approve of this site, but yeah, for studying bullshit things like these, we can use it. Just a second, yeah. So basically, it's just a term. I told you, right? It's written tabulation is basically what I can get a grab of it is that I made the DP array that was computing things, right? So that DP array, when I was making it for a bottom-up DP, then it was tabulation, and when I was making that DP array for the top-down thing, then it was memoization. The point is that memoization makes sense with recursion. Means we always say recursion with memoization, right? That is the thing. Basically, these are just conceptual things. These are not of much help. In DP, you need to code questions, and that's the thing. But even if you want to know, the point is that recursion with memoization. Recursion is of like if you are memoizing it, we are remembering that we calculated something, we are remembering it. And tabulation is just the same method that is being used in a bottom-up manner. I don't find any other difference. Like,
Yeah, it's just a fancy word for it.
yeah,
That's not.
that's just a fancy word, so you can skip that. The concept is the main thing, regarding top, down, and bottom. Right? So let's get back. The slide is being is visible to you, right? I'll assume it's visible.
Yep, it's visible.
So minimum steps to one. This is the question that we have. You guys can give it a good read, and if any one of you has a problem, I'm there to answer. Right? It's very simple. Like on a positive integer, you can perform any of the following three steps, right? So basically, if you are having an integer x, you can make it x minus 1, right? On a positive integer, right? And if it is divisible by 2, then I can make it x by 2. And if it is divisible by 3, then I can make it x by 3, right? So I am having a particular number x with me, and I need to reach 1 as soon as possible. So basically, making it x to x minus 1 is one operation. Making it x to x by 2 is also one operation, and x to x by 3 is also one operation. So basically, you need to reach 1 quickly. So if I have 9 as my number, then I'll simply divide 9 by 3, it becomes 3, and I'll again divide it by 3. So it becomes 1. So I needed two operations. So the answer for 9 should be 2, right? The other way could be that I would subtract minus 1, minus 1, minus 1, then I reach 6, right? So 3 operations to reach 6, and then 6 by 3 is equal to 2, and then 2 by 2 is equal to 1. So 2 operations over here. 5 could also be an answer, but obviously if we can reach 2 in 2 operations, then why not use that, right? So that's the question. We need to find out the minimum steps to reach to 1 from any number. So we'll be given a number x, and the range of the number is also mentioned over here. It is 2 into 10 to the power 7. Does anyone have a problem with the question? Like you need to write it on the chat. If anyone has a problem with the question, we have 3 test cases as well. One, no sir, okay. Like 1 is there, then answer is 0 because I'm standing on 1, right? So no 0, and so 4 for 4 the answer would be 2. 4 by 2 and 2 by 2. That leads me to 1. Yeah. So the problem statement is clear to everyone. So let's try writing code for it in both bottom up and top down, right? So I'll be writing the code for it. Let me share my screen. Just a second. I'll be switching it quickly. Yeah. So hopefully you have reached the code part, right? Right, Meg sir?
Yep.
So I'll first of all write the bottom up code, right? So it's 2 into 10 to the power 7. Like I have to compute the maximum up till 2 into 10 to the power 7, right? So I'll make an array of size 2 into 10 to the power 7 plus 1, right? To be on the safer side. Now I'll have a number n, right? Okay, so first of all, I'll be having the test cases t. I'll be running for each test case. Now, the next thing would be, I'll make it int. So first of all, I need to calculate the answer, right? In bottom up, I'm not calculating the answer for each person again and again. So I need to initially calculate answer for all of them. So I'll be jumping from 2 because the answer for 1 is 0 only, right? So that's initialized to 0 only. So I'll be going till yeah. So yeah. Now dpi can either be equal to dp of I minus 1 plus 1, right? Or if I modulo 2 is equal to 0, then dpi could also be equal to minimum of dpi, comma, dpi by 2 plus 1, right? Basically, the point is that I'll explain it to you. So basically, the number of steps to reach 1 is 0 from 1. From 2, it's 1. From 3, the number of steps required is basically 2. And from 4, basically 4 can either go to 3 and by losing one operation, or 4 can either jump to 2 by losing one operation and then go from 2 to 1. So basically, you can see the sub problem or the optimal substructure thing, right? This is the substructure thing. Basically, if I want to reach from 4 to 1, I need to use the minimum amount of steps, right? From to reach from 2 to 1 also, I need to know the minimum amount of steps. So this is being stored over here. 1 plus 1 is basically 2. So basically, the minimum steps to reach from 4 to 1 is 2. Or either 4 can go to 3 and then try to see how many steps it does it take to reach from 3 to 1. So it will be 1 plus 2 because 3 takes 2 steps to reach to 1. So now, similarly, if I modulo 3 is equal to 0, then my dpi would be equal to minimum of dpi I by 3 plus 1, right? So that's the thing. Now, I'll be having some input n. I'll take it, or I can write it as that's just a test case thing which I'm handling over here. It's not of much use. You need to realize the concept. That's it. K slash. Okay, I'll see the way they have written it. K slash pt colon space dp of n. Right? dp of n actually stores the answer. So that's the thing. We'll try running it on the test cases we have. 3, 1, 3, 1, 4, 7, right? Okay, so nothing got printed. Yeah, so actually I'll have to take the test cases also, right? C and T. That's one thing. 0, 2, 3. Yeah. So we are getting the correct answers for all of them. I'll try submitting it in front of you. You can practice from Scotch, Code Forces, any other site like this. So I'm just giving you a demo of how you can submit it. You just need to paste the code over here and click submit. Your code will be running over there. And if you get an AC, that means that you have correct answer. Else you have committed a mistake if you get a wrong answer. Yeah, so we have got an AC. You can see it. Now, does someone have any issue with the bottom up part? If not, then I'll be jumping onto the top down part for the same thing, for the same question.
I think it might be better if you just give a quick overview of the code once again before jumping into the next one.
Yeah. So basically, like every number I has two options, right? You can see the screen. Every number I has basically three options. If that number I is a multiple of 2, then I can either take the answer from dp of I by 2 and then add 1 in it, right? Because one operation is what I lose when I go to I by 2, right? And plus the number of operations of reaching from I by 2 to 1, right? The other way could be that I is a multiple of 3, then I reach I by 3. But the point is that in here also I lose one operation because that's considered as one operation, right? Or if that I is not a multiple, like may or may not be multiple, but this is a multiple independent condition, right? We can have it reduced by one as well. So like we need to find out the minimum amongst these, but these are to be considered only when the number is a multiple of 2 or multiple of 3. That's the thing. So that's why I have written this dp of I is equal to dp I minus 1 plus 1. And these two are conditional things, right? So that's why these two lines, 97 and 99. And whenever I get a particular test case anytime, I just print out the number of steps to reach one from that particular position. So yeah, is it clear now?
Guys, any questions?
You can tell me on the chat whether you have any questions or not.
Yeah, if it's clear, just say yes so that we can then move forward. The Zoom thing doesn't say if somebody's typing something, so it's hard to tell if somebody's actually typing in a question and we wait for it.
Okay.
Alright, cool, clear.
I got it from one person.
Yeah.
I write it others as well.
So clear. Alright, cool. So far no questions, so let's just move forward. We can come back if there are any questions.
I will do for top down now. So in top down, obviously you always have to memorize. You have to always mem set it to -1 because that condition has to stay, because you need to know whether you have computed it or not, right? And -1 cannot be the answer of any of the problems. So yeah, it's a good way to mem set it to -1. So solve. Sorry, I'll have the solve function that takes in the number as it is, and I'll be copying this entire thing over here. So first of all, it will be that if I is equal to 1, then I simply return 0, because this is the base case, right? I need to code the base case. And if dp of I is not equal to -1, then I return dp I. Else, in the other cases, I compute it, right? But the computation part here is not correct because this is a bottom up manner. In bottom up, these are already calculated, but in top down, we cannot assure whether these dpi -1s are calculated or not. So I'll just replace it with solve I minus 1. So everything would be replaced by solve and solve again, right? As simple as that. We do not need this computation. And every time I want to find out the answer for a particular person, I'll just see out solve of n, right? So that would be the easy code for this thing. Okay, so I've got some bug over here. Solve of I by 2 plus 1. Okay, so basically they are type mismatch. That's it, nothing else. I'll make it as int, and this also as int. Then things will work. Do it, yeah. Yeah, so I need to return dpi. Yeah, so we have again got the correct answers 0, 2, and 3. So you can very easily see that how I changed the code from bottom up to top down. Like it's entirely the same concept. Just it's just that we have made it recursion instead of an iteration. I can try submitting this as well for you guys so that you know whether this is working fine. Just for your belief. Yeah.
We trust you.
Yeah, but still sometimes I don't trust myself, but it worked. So we got an AC on this as well. So does anyone have a doubt in top down? I want to know that. The code for top down is very similar here for bottom up, but there are many cases in which the code for bottom up becomes like hell tough, because here you are just able to see one dimension, but there can be 5, 6, 7, 8 dimensions in your DP. So in that case, you have to write top down. So yeah, any questions? I don't think anyone would have questions because it's quite easy. I'll jump on to the next part. It is knapsack problem. So I'd like to know on the chat how many of you know about knapsack problem. If every one of you knows, then okay, I'll skip it. I'll try to explain something new to you. I'll ask it. How many of you?
Anyone knows the knapsack problem? Just say yes or no, so that either we can cover it or we can skip it. I'm guessing we'll have few that don't know the knapsack problem.
Okay, that would be great. Means I'm anyways okay, but yeah, I would like to teach something which they don't know rather than something which they already know.
Okay, I definitely don't know the knapsack problem, so please do go
So
ahead.
that would be great. Then that's okay. That was required. That's okay.
All right, cool. We have few more, so yeah,
So,
let's cover it then.
open up the problem first of all. Yeah. So the famous knapsack problem. You are packing for a vacation on the seaside, and you are going to carry only one bag with capacity this. So you can give it a read. But the question is very simple. You actually have a knapsack of a particular size. Like you can consider it as a suitcase that you are having. You are going on a vacation and you have a suitcase which is of size S, right? And you have some things that you have that are of particular sizes S1, S2, S3, S4. But you have many such things. Like you have, let's assume, 2,000 such items that you want to put in your bag, but obviously your bag has a limited capacity, right? Right?
Sam, could you just tilt your screen a little bit low because the bottom half of what you're writing is getting cut off in your webcam. Yeah, much better, much better. Cool.
So S1 to S4, like these are the sizes of the items that I have, and S is the size of the suitcase, the knapsack that I have. So I want to put in these items in my knapsack somehow, so that I take many of my items, but many of the items is not a thing. I also have some values for each of them. Like obviously, if you have two items with you, some item is more valuable to you, right? So if you are having a suitcase and it's completely filled, now you need to fill it. You can fill it just by one thing extra, and you have a watch and a mobile phone. So in my case, that would be mobile phone, right? In everyone's case, that would be mobile phone, right? So mobile phone actually has a more value. So basically, you have some values assigned, and these are numbers. These are not emotional values; these are numbers that you have assigned. So it can be up till 100, like 100 or anything. I'm just assuming that they have some values. It can be even up till 10 to the power 9. I don't care. But the point is that I need to somehow fill in these such that I am happy, right? When would I be happy? When the values, the sum of the values would be maximum, right? Because if something is more valuable to me, then I would like to have more such things so that the sum of their values is maximum, right? Even though it's a less important thing, right? Like less as, like if I can have accommodate a very less amount of things, right? So let's see an example. For example, the size of my knapsack is 10, and I have an item of 10 size, but its value is 100. I have many other items 1, 2, 3, and 4, each of value 1, right? So the point is that I wouldn't take any one of them. I would just take this and be happy, right? Because I'm having 100 value, like that's most valuable thing. So that's why I'll take this. But now let's assume that instead of this, I was having two things which were having size 5, and each one of them was having value 60 and 70. So now I would prefer to take these both because their sum of values is 130, right? So this is the explanation for the problem that we have. So any question with the problem, like first of all, you should know the problem correctly before solving it. So let me check. You can
So
tell me.
just to iterate, the problem is that we have a capacity that we want to fill to the maximum
Yeah.
while maximizing value of each of the items that we are carrying, correct?
Yeah.
So on the example where that's visible on the screen, so you have 4, 5 as one, right? So that means that 4 is like the weight and 5 is the value from the context that we just discussed, correct?
In here, basically they have 4 as the total size they have. Like
Okay.
4 is the total size of the knapsack, and 5 are the items that you have. In this test case, there's an item with size 1 that has value 8, one item with size 2 which has value 4, one item with size 3 which has value 0, one item with size 2 which has value 5, and one item with size 2 which has value 3.
Cool. Yeah. Okay. Clear.
So basically, in this case, it will be good to accommodate the first one and the fourth one. So the first one has a size of 1 and the fourth one has a size of 2. So both of them add up to a size of 3 which is less than equal to 4, and the qualities are 8 plus 5, or the values are 8 plus 5, 13. So that's the maximum value we can get. So that's why my output is 30, right? That's the test. I'll get on to the question he has written on chat. We need to fill it with so we get the most valuable loot at the end with the sack full. An example will be like, yeah, he has written. Yeah, you can even see the problem on chat. He has written quite a good example. So if you are a thief and you know values of various things in the house, you have a particular size of your knapsack, right? So if you are a thief, you know that you have to maximize the loot you have, right? Maximize the sum of the values that you have. So if he needs to fill up with some values, then obviously he would like to have the summation of the cost, the summation of the values to be maximum, right? That's 0, 1 knapsack. Yeah. So basically, that's 0, 1 knapsack. Yeah. So are you guys aware of it?
So I think since majority said they want, so
yeah. So I'll continue. No issues. So the point is that now is the problem statement clear to you guys? I hope the problem statement is clear.
yep.
Yeah. So
Don't see any questions. So
I'll write it out for the given problem. Given test case, basically I have 0, 1, 2, 3, 4. Right? 4 is the maximum size of the size I want, and then I'll be going on from 1, 2, 3, 4, 5. Or I'll be having 0 item, 1 item. Are the numbers on the board visible to you guys?
they are, but it could be slightly bigger. That'll help. If you're planning on writing something within the grid, that would have been really tiny. Yep, better.
So these are the 5 items and the 4 sides that I have, right? So first of all, let's start with 0, 0. Okay, so if you have a size of, let's say we have 0 size capacity and we have 0 items. Okay, then that's good, right? Then basically the sum of values you can have is 0, right? Because if you don't have a size, then how would you accommodate anything in it, right? So 0 very simply. Now let's see, this is for size and this is for the items. So the 0th item means nothing, including nothing, right? So if you have a size of 1 and you have 0 items, then actually it doesn't make sense, right? So because if you don't have items, then even if you have a good size, what will you be putting in it? Nothing, right? And similarly, if now you have a 0 size, then also if you have one item, then no matter what its size is, like if size obviously is a positive term, right? Size is obviously greater than equal to 1. Then these also don't make sense, right? Because I have a 0 size, so I cannot even accommodate 1 item, 2 item, 3 item, any of them, because they have some size, some positive size. So I cannot put them in the answer, right? So these are correct. Like filling the first row and filling the first column with zeros is correct. But this is where I don't know the values and I'll be putting them one by one. So let's assume that I have a knapsack of size, like I have size 1 knapsack. So basically, getting on to item 1. Item 1 in here has a size of 1 and a value of 4. Right? It's written in the, I'm just doing it for the sample test case. So item 1 has a value of 1 and 4 as its weight, or size of 1 and 4 as its value, right? So basically, now what's the question? I have a knapsack of size 1 and one item with a value of 4. Now obviously you think that okay, I'll fill it. Why would I not fill it? Yeah, so we would fill it. Very simply, 4 would be the answer over here because 4 is the value of this particular item. I'll be putting on the maximum values that I can get in this matrix. Right? This matrix will actually contain the maximum value that I can get for this particular size and these items. Right? So basically, when I'll be considering 2, then I'll be actually considering all the 0, 1, 2 items. Like 0 means nothing, but 1 and 2 items I'm considering. When I'm on the third row, then it would mean that I'm considering 3 items that are to be put in my knapsack. I can put any one of them. But the point is that each time I get on particular row, then I'll try putting that particular item. So I'll put 4 simply over here. Now, if my size is 2, but I still have just one item, right? With a value of 4. So I can fill it with 4, again with the 4, again with the 4. Because I'm just having one item. And if the size increases, obviously if I could put it in a smaller size bag, then I could obviously put it in a bigger size bag as well, right? So that makes sense. Now jumping on to 2. Now things would be clearer to you. So now the second item has 2, 4. It has a weight of 2 and a value of 4 again, right? So now it's a 0, 1 knapsack problem. 0 means that I'm not taking it. 1 means that I'm taking it, right? So if my size is 1, right? So if my size of the knapsack is 1 and the item which I'm present at presently is 2 in size, then actually I cannot accommodate it anyhow, right? So I'd just be using the answer present on the top, 4. This means that 0, I am not taking this. 1 means I am taking this. So I am not taking the second item because its size is 2 and the size of my knapsack is obviously lesser than that. I will start my consideration when the size of the knapsack actually becomes equal to the size of the item that I have. So this is the point where this happens. Now my size is 2 and I have an item of size 2. So there are 2 options. I can either take it or not take it, right? If I don't take it, then my value is 4. I'll just fill it with one item, that's a value 4. If I take it, then now the question is that if I take it, then what's my remaining size? My remaining size is 2 minus 2, 0, right? And what are the items that I need to consider? Items up till 1. So basically, the answer over here would be 4 plus the value over here, because I'll be having 0 size plus 1 item. So sorry, 0 size and 1 item. Yeah. So 0 comma 1, 1 comma 0 would be the actual position. The value over here plus this the value of this. So it's basically 4 plus 0, or I'll just have this 4 from here, right? So eventually both of them are 4, so I'll have my answer to be 4 over there. Like no one of them is max greater than other one because they're equal. Now I'll again think in the same manner to fill in this. So now I have a knapsack of size 3, right? So in a knapsack of size 3, now you can see the beauty of DP comes over here. Now I have a knapsack of size 3, right? So I can either put it or not put it. If I don't put item number 2, then its value basically stays out to be 4 only. But if I put 2, right? If I put the knapsack, if I put the item 2, then what's my size now? My size now becomes 3 minus 2, which is equal to 1, right? So I have one size, and what are the items? Because I cannot have 2 or more items of this, now my items are basically 1. I can just have any of the items from here, but I am done with the items, this item. So basically, now the answer would be 4, the value of this item, and the value at this row and this column. So 1 comma 1, the value is 4. So 4 plus 4 is 8. So the maximum of 4 comma 8 is 8. So my answer over here becomes 8. Now you can, if you would have been there, normally also you can see that if I have a size 3 as of my knapsack, and I have 2 values, 2 people of one of size, 2 items, one of size 1 and one of size 2, each one of them having value 4, then obviously I can put both of them, my answer would be 8. So that's how DP calculated it, right? Now, now I have a knapsack of size 4, so I can either have this or I can either take this. I can either not take this or take this. So if I don't take this, then the answer is 4 from the up from the previous row. But if I want to take this, then it's the value of this plus. Now, if I include this, what's the remaining size of the knapsack? The remaining size of the knapsack is 4 minus 2, which is equal to 2. And what are the items? I can just take one items, like every item before 1, not further. So it will again be 4 plus 4, which is equal to 8. So the max of 4 comma 8 is actually 8, right? So yeah, that's how it's done. Now I'd like you to fill it yourself, but yeah, I'll help you out. The third item is actually 3 comma 0. It's of size 3 and its value is 0. So obviously you can think that why would I put a thing of value 0? It's not useless, right? So 3 0, I'll jump on to size 1. Now if my knapsack size is 1, I can either have it. So the point is that 3, I cannot take an item of size 3 until my knapsack is of size greater than or equal to 3, right? So in this, I'll eventually copy all the values from top up till we reach 3, right? When we reach 3, we can actually consider it. So whenever I reach 3, now I have a knapsack of size 3. But if I fill it with it, then the size becomes 0. And I have 2 items now to be considered, right? Because, so if I take, I'll go here. If my knapsack is of size 3, then if I put the item number 3 with a size of 3, then my size becomes equal to 0, right? And the items become equal to 2. Because if I'm not taking the third item, I can take any item up till the second item. So it becomes actually 0, 2 second row's 0th column, which is this, right? So either I can have a 0 over here because the value of this is 0. So 0 plus 0 is 0, and or either I can not take it. Not taking it is more beneficial. So I'll have it 0, 8 is 8. So now, by seeing it so much, we can very easily see that I either have to take this value from the previous row, just the corresponding the value which is present up over it, or this value minus the size from the previous row, right? Very simply. So it's 8 comma the value is 0, 0 plus 4 minus 3 is 1 from the previous row. So first column from the previous row, which is 4. So the maximum of 8 comma 4 is 8. So I'll have it 8 over. Now we'll do it quickly now. So 4. The fourth item is actually of size 2 and of value 5. Right? So now we'll skip through it. Obviously, size 1, it doesn't make sense because the size of the item is 2. We cannot accommodate it in knapsack of size 1. Now, going on to knapsack of size 2, then 2 minus 2 is 0. So 0th column of the previous row plus this value 5. So this now becomes 5. Right? Now, third 3 is the size of my knapsack. 3 is the size of my knapsack that I am having, and 2 is the item that I want to put. So either my answer would be 8, copying it from above, or 5 plus 3 minus 2. 3 minus 2 is 1 from the previous. So this is the value 4. 5 plus 4 is equal to 9. So yeah, the maximum of 8 comma 9 is 9. So I'll be writing 9. Going beyond this, the size of my knapsack is 4 and the size of the item is 2. So 4 minus 2 is equal to 2. So I can take the value to 4 from here. 4 plus 5 comma the upper value, which is 8. So 4 plus 9 comma 8, again the maximum is 9. Right? And beyond this, we'll go in a similar manner. Last item has a size of 2 and a value of 3. So, yeah. Okay. So actually, I took the wrong test case from there. The initial one was 1 comma 8, right? So that's why my answer would be lesser than their answer because I took it as 1 comma 4. But the point is that the concept should be clear to you. So now taking the 2 comma 3 part, the size is 2, so I'll be copying it from here 4, and now so basically you can eventually see I can fill it without seeing anything from above. It will just be the same from here. No additions made because taking this item is obviously useless because we have 2 items which can help us out anytime. So it would be the same, but you can try filling it in the same manner. My answer would be 9. Their answer is 13 because they have considered this one as of size 8. So this one of value 8, the size is 1. So that's why their answer is different from mine. But yeah, that's how we'll be using it. I'll write the code for it so that you get a better grip of it. I'll not erase it. So yeah, does anyone have a doubt in this? Please let me know.
Yeah, guys, just go ahead and put your questions in the chat. So one question,
Yeah.
in general, so when you start working out the calculations in the grid, right? So for the first row, for the second row, we were doing it manually, right? Like always going, okay, what will be the exact answer? Should we add this? Should we not add this, etc. But when you got to the second row and the third row, we came up with a formula that, okay, we're going to take the current size, subtract it to this. So that transformation is important to understand, right? Like once you start writing something down and filling individual use cases, how do you convert it into a generic formula based on the pattern that you're seeing
Yeah.
and make that as the general solution going forward, right? Like, so how do you come up with that while you're solving it?
So basically, you could very this was quite intuitive to think of it, because every time we were putting this, like there are two cases, right? Either we put that particular thing into the knapsack, or we don't put it. If we don't put it, then we simply put the value from the previous one, right? That's very simple. But what if we put it? If we put it, then the size of the knapsack that we have in hand obviously decreases by the size of this particular item, right? So if I put an item of size 2 in my knapsack of size 4, then my item size actually becomes 2. 4 minus 2 is equal to 2. And I have one less item to be considered. So that's why I'm going in the previous row. And the size, the column is the size minus the size of the knapsack minus the size of the item. As simple as that. So I tried to show you in the first two rows that thing, so that like then it becomes intuitive to you. So basically, the first two rows were filled by that thing, but once you get to know, start getting to know that, okay, yeah, things are functioning like this. That's why I started filling later on in the same manner, because we created a formula out of it, right? But that's pretty simple. Like that's the entire thing of it.
Got it. Yeah, so I think just a general sort of thing for everyone here to learn is basically, I've seen a lot of people. So when I give sort of some kind of a interview question, right? People kind of generalize it, start solving it. Oh, okay, what will happen for case one? What will happen for case two? But now they have to generalize it. What will happen for case 100? Right? Obviously, I'm not going to sit there for 1 hour looking at you solve 0, 1, 2, 3, 4, 5 all the way up to 100. Right? You got to generalize it. So whenever you make that general formula after solving the first 3 or 4 cases by hand, always go and solve one or more case by hand and the formula, and verify that your answer is by formula and by hand is coming correctly, right? Because what happens is that the first formula that might seem that runs and fits the solution might not fit for any other cases going forward as well. So try and do that as a mental exercise, that okay, on row 2 we figured out that this is the general formula, and it's more of a practice thing for any kind of question, not just this question. On row 2 you figured out this is the general strategy, that this is the formula I'm going to apply to fill all the other grid cells, right, all the way going up to 100. But even on row 3, still apply the formula, get the answers, but verify that the answers are still correct even by manually doing the same thing that you were doing till row 2 before you came up with the formula. So that you can actually get a better sense of that whether your formula is correct or not. It might seem that your formula is correct till row 2, but it might fuck up in row 4, and you would never realize, because by the time you were convinced that my formula is solid,
So
right? Does
the
that make
point
sense?
is that you shouldn't be finding patterns. Instead, you should be finding logic in your uh,
Exactly.
in the problem solving part. Obviously, patterns would help you out somewhere, but yeah, logic would obviously help you out everywhere. That's the thing. So
Yeah.
I'll be coding for it so that you are able to better visualize things. I'll be writing a bottom-up DP. So, like, are you able to view the coding screen now?
Yep.
So I'll first of all see the N and S. N and S. I don't have test cases over here. So seeing S and N. My DP array is actually what? The size of the DP array could be 2005 cross 2005, right? Because the size and the number of items N into S, that's the maximum size of a DP array, right? So I'll make it as 2005 plus 2005. And the first two rows that I'm going to fill in it, I'll fill in the first column and the first row, right? So I is equal to 0, I is less than equal to S I plus plus, and dp of 0 I is equal to 0. And similarly, I'll be filling in the first column as well. Very simple to fill it. Yeah. I'll be also having an array of size and the value, right? The size and the value of each one of them. So LL here basically is a macro for int or long int. I can have anything. So to be on the safer side, we can make it LL. But yeah, actually, the summation of values would not exceed, so we can keep it int as well. So I'll has define my LL to int only because the values won't exceed. Now I'll be filling in the rows and the columns one by one. So j is equal to 1 to s and I is equal to 1 to n. And we generalize the simple formula, right? So the formula was dp, like whenever this j is less than the size of I, right? Okay, I need to take the input first. So I'll take the input on the go. So if j is less than size of I, then I simply copy the value from the previous row, right? So dp of ij in that case is simply equal to dp of I minus 1j, right? In the other case, what is dpij? dpij is equal to maximum of dp I minus 1j, not taking this value or taking this value, but by reducing the size, j minus szy. This was what I was performing. But since I'm taking this value, I need to add its value also to my sum. So value of I. This is what I did over here. I'm just writing a simple code for it. Now the final answer would be in dp of n, taking all the n items and filling it with size s. So like filling the knapsack of size s. So dpns should contain my answer. For this test case, my answer should be 13. So let's verify that. Yeah, it's coming out to be 13. So we'll try submitting this solution. For the bigger test cases as well. Yeah, so we have got an AC. So that's the entire thing. I just coded what I thought. It's just sometimes you need to realize that the point is that even if you are able to think good, if you are not able to convert it to code, then it's as bad as not thinking of it, right? So in dynamic programming, you need to think, and then the code part is always simpler in dynamic programming. The thinking part is obviously tougher. But yeah, you should be able to convert that thought process into code, right? So let me see if someone has a doubt. Can you please write in the chat if anyone of you has some doubt or any other thing you might want to know in the knapsack, any other thought.
Yeah, guys, if you have any questions, just type them out. If you're question free and everything is clear, just let us know also in the chat that everything is clear.
Can we have a divided knapsack? That is, yeah.
Okay. Cool. Seems like it's a longer answer. Or is it like, are you splitting the knapsack into two different knapsacks and seeing what is the best way to optimize it or something like that?
I'm thinking of it like, can you listen to me first of all? Yeah, I think that the question is that you are having two knapsacks of size 10 and 10, and then you are trying to fill them so that you have the maximum capacity, like fill them with some items so that eventually you have the maximum value, right? Is it something like this? Like,
He's saying nah. So I don't know if he has a thief buddy to carry second knapsack.
okay.
But yeah, okay, cool. So just let him write. Anybody else? Any questions? If it's clear, just say it's clear, so we know that.
Number 6, yeah. Okay, so let me think of it. You are saying that we are having a knapsack, right, of some particular size, and we need to maximize the value of the things we put in it. But each item can be divided, right? This means that each item can be broken into pieces of one. So, like, is it the thing you are asking? Like, each item can be broken up into pieces, one-sized pieces, and then yeah. So this is the question he's asking. Okay, so I'll be releasing this and because it's clear, but this is the next question in hand. So we'll try to solve this. So basically what he's saying is that I have a particular item Z and it has a particular value, let's assume, right? As simple as that. Now let's assume that we have an item of size 3 and value is 10. Then what he's saying is that the value is divisible, means that I can even take an item of size 1 which has, so its value would be 10 by 3. Basically the value is divisible in its uh, children. So if I take an item of size 2 from here, then its value would be 2 into 10 by 3. And if I take the entire item, then its value would be 3 into 10 by 3, which is the actual value. Right? So the value is divisible. That's the question he's asking. So in that case, how would we fill the knapsack? So is the question clear to you? First of all, that's the thing. He has written it on the chart as well, so you can get an idea of it from there as well. But the value is divisible. So actually, even if you have a 10 kg thing or 10 size thing with you, you can take just one piece of it, right? So can you please write on the chat whether the question is clear so that I can progress towards its solution? Yeah. Okay, this will like it will take me 5 minutes.
Sam, is that Mohsin?
I don't know, but he said that the room is booked for them. So he said I told him that I'll not take more than 5 to 10 minutes.
Okay, just in case if you need slightly more than that, just let him know
Yeah,
that.
if you want, if I want to end up at this problem which he has asked, then I can end it over here. But if I want to have one more problem, then it would take half an hour more.
Okay, I think we can wrap it up at this problem because then, like after 2 hours, like just the absorption property of the brain slows down as well. So it'll be good to stop
So,
after we discuss this. I think like nobody's mentioned anything, so let's move forward with
yeah,
the solution.
so the solution is very simple. Like the solution is not at all deeply. Now the solution is green, right? I'll let you know why. But let's assume that we have 3 items. I'll take it from this only, like the question which I had. So one item of size 1 and 8 value, other item of size 2 and the value is 4, and the other item of size 3 and the value is 0, 2 and the value is 5 and 2 and the value is right. So this is the case. Now how will I solve it? So this has, I'll calculate the per item values of each one. Right? So 8 by 1 is the value over here. 4 by 2 is the value of here, but I have two such items, right? 3 by like sorry 0 by 3. 0 by 3 is the value over here, and I have how many such items? Like many such items, infinite such items, but no use. right? And 2 by 5, I have 5 by 2 and 3 by 2, right? The values are clear, right? So, thinking of it in a very greedy manner, now I have to fill the knapsack of size 4, let's assume. So, who should be the first person should get it? Like now I go greedy. So I should take the person who has the maximum per unit value, right? So which is 8. So I'm for sure putting an 8 over here, right? Now next would be the person who has the next highest value. This has been exhausted because it just had one item. Now this is 2.5 and I have two such items. This is 1.5 and I have two such items, and this is 2 and I have two such items. So obviously I'll be picking the 2.5 one now, right? So 8 and then 2.5, 2.5. Now this 2.5 is also exhausted, right? Now I'll be removing this and removing this. Now what all I have? I have now this 1.5 two items and two items. So I'll take just 2 item because now my size is filled. 1 unit, 1 unit, 1 unit, 1 unit. So it's 4 units now, and my maximum value can be 8 plus 2, 10 plus 2.5 plus 2.5, 15, right? So each time I am actually putting the person, putting the value which is greater, right? Which is the greatest amongst all. So as simple as that. Like the per unit value should be maximum. So I'm putting that particular person, and obviously we have we have divided this. So in here, what's happening is that this can also be solved using DP. Obviously, DP can solve anything, but the point is that here the values have changed. Now each item is of size 1, and like first of all it has 8. So now second item was 2 comma 4, but it becomes 1 comma 2 and 1 comma 2, right? And similarly, so the point is that any problem which can be solved by greedy, that can surely be solved by DP. But yeah, sometimes greedy is obviously a lesser heat to code and easier to code, and obviously it takes lesser time. So the next would be 0 doesn't make sense. I'll make it 1 comma 0 as well. But the next item would be 2 comma 5. So basically now we have two items of size of values 2.5 and 2, right? And after this, two more items, one of size 1 comma 1.5, 1 comma 1.5. So basically now each one of them has become an item of size 1 and a value 1.5. Oh sorry, value whatever, the per unit value, like the value divided by the size. So I can even apply DP over here now, or I can just pick out the maximum ones because each time each one of them has an equal size. So taking no lesser or no greater would help us, right? So each one of them is equal in terms of size. So I can pick anyone greedy. So that's how we can disperse the problem into simpler problems. So I'll see if, yeah. So is it clear to everyone? I want to know it.
Cool. I think that should be clear. Ian, okay, others, yes. Alright, cool.
Two people have replied with a yes, and it includes the person who asked the question. So I guess it will be clear.
Yeah. Cool. Awesome. Overall, I think any question, guys, if you want, just like Vijit has one more question. Can we do something like normalize the problem to
Yeah,
greedy?
we did it, right? We normalized the problem to greedy only. Oh, in that case, no, cannot do that, right? Because in actual scenario, we cannot disperse it, right? We cannot break it into smaller parts and put it, right? So this could be dispersed because we had the power to take per unit values, right? We had the power to take 1 kg, like items of size 1. We had the power of breaking it. But when we don't have the power of breaking it, then the actual knapsack problem cannot be taken into greedy, solved, and coming back. Like no such DP problem can be solved like this. It's not general for, it's like general for all the DP problems. You cannot go greedy by transforming it into something and coming back to DP to solve it. For greedy problems, you can go from greedy to DP and then come back with an answer. So that's the case. So is it clear? Yeah. You understood.
All right. Anyone else? If you guys have any questions, just post them in the chat or
Yeah.
post them on like Discord or something as well after the call, just in case any questions come
Yeah.
up.
Eventually, I'll write this as a Venn diagram of greedy and DP problems. So greedy is basically a subset of DP, right? So DP problem can be surely, like greedy problem can be surely solved by DP, but DP problem is not necessarily, cannot necessarily be solved by, right? So this Venn diagram makes it clear, I guess.
Cool. Yeah, something like that. All right, awesome. Cool. So, any overall closing thoughts from you, Sam? Is there anything on the sheet, like your presentation or anything that you had after this that
I
you
didn't
wanted to
have many
cover?
things, but yeah, that sheet I made for a 4 to 5 hour class at least. So there are many things to cover on it, but yeah, DP will eventually come to you when you practice it. So it's nothing like you can get DP in a day. You learn 2 problems and you can solve any DP problem. It's never going to be like that. You have to practice lots and lots of DP and the overlapping subproblem or optimal substructure. These are more of a theoretical things, but you need to get into coding DP questions so as to get a better grip of it. So that's it from my side. Like that's the whole thing. You need to practice DP. Like it's with competitive programming. You need to practice it to get better on it. We just had a taste of DP for today, right? Yeah. So you just had a taste of it. Not just like it's not even a starter. It's basically just a sip of it. So just a sip of the starter you had. But yeah, but if when you go through it, when you go through various problems, then you get to know how things actually work in DP, and you really would love the problem. Like it is my favorite topic. So yeah, you should have, you should get a better grip of it. You can solve problems on Code Forces, Code Chef, Scotch. I would recommend you to solve problems on Code Forces. Like it's a site that can actually build your thinking ability from nothing to everything, bottom up.
Hmm.
So
So normally, would you use that? Was that what you primarily used as well when you were preparing and all? So, or something else?
no, basically, I was using Code Forces only entirely. But initially, I started with Squad and Code Chef. But I strongly recommend everyone to start with Code Forces only and keep it up to there because Code Forces in a site itself is covering everything else. So that's not an issue.
Got it. Got it. And earlier you dismissed the uh, Geeks for Geeks. That seems to be very popular with, like, in general, the Indian community. So, any
Yeah,
specific reason for that?
yeah, I got the question, but the point is that people are cramming things from there, from Geeks for Geeks, and like omitting out in the interviews. So I don't like that concept being going on. So we in our college actually like our batch we prefer that okay we'll not even touch Geeks for Geeks. Yeah, so we'll not touch Geeks for Geeks at all for it. So you should practice more on Code Forces and that will bring everything to you. Like you'll be able to clear your interviews. And now I have to go because a person is standing outside and he wants to take the room. So
Cool, cool, cool. No worries. All right, cool, awesome. Thanks for stopping by today. Really appreciate it. So we'll take the conversation offline after that. And guys, if you have any questions from the today's lecture, just feel free to put them on Discord, and I'll share it with Sam as well. All
thank
right, cool.
you.
Thanks, guys.